So in the previous video, we finished off with this problem and we said that we were trying to graph it, but we couldn't because we felt that there was another zero that was missing or else the end behavior wouldn't make sense. And when I said that the culprit was this guy, so what happened? Well, the thing here is that you actually basically have this zero twice. This squared tells me that I have two of these zeros. Okay, how can you have two zeros? What does that make? What does that mean? Well, I don't really mean two zeros. I mainly mean repeating zeros. And this is what we call multiplicity. Okay, so multiplicity is basically how many times a factor repeats. Okay, so the number of times that this particular factor repeats. And here is basically the rules. So the rules are if multiplicity is odd, the graph will cross at the root. Okay, so at that particular root that we found, that zero is just going to cross it. Okay, if multiplicity is even, okay, so if you have an even multiplicity, the graph will bounce or touch. I like the word bounce at the root. Okay, so the graph is going to just bounce at that particular root, at that particular zero. So if I go back to this guy, the factor, the power tells me what the multiplicity is. This zero has a multiplicity of 2 because there's a 2 in here. That means that this thing is even, which means that a zero is going to bounce. So let's redo this again. Okay, so let me go ahead and redo this guy. Okay, so we had this guy. We had all of these particular roots that we found last time. And what we want to do, let me write this as square root of 2 again. Okay, so here were all my points. So it's going to cross everywhere. So notice that this has a multiplicity of 1, multiplicity of 1. This guy has a square, so it has a multiplicity of 2. Okay, so what we're going to do is that everything is going to cross except this guy is going to bounce. It's going to cross through square root of 2, negative square root of 2, cross through 1. It's going to bounce at 0. So it's not going to cross it. It's just going to bounce back up. It's going to cross through 1. Cross to square root of 2 and then go back up. There we go, and everything is well in the world. Okay, so there is what the graph kind of should look like, or you can kind of get a glimpse of what the graph is. Okay, so there the multiplicity plays a really big role in graphing these types of problems. Now, what would be the criteria or the steps to graph a polynomial function? Okay, so I'm going to give you some general steps on how to do it. The first thing that you kind of want to think about is you want to find the zeros and the multiplicity, because this is going to determine if something's going to bounce or cross. Okay, the second thing is find end behavior. So find the end behavior and the number of terms. Number of terms. So how many turns is this guy doing? Okay. And the third thing that you might want to consider doing is find the Y-intercept if you want to. Usually this is actually really useful to find any additional points so I can tell you how low or how high this graph is going. Okay. So the best way to just do learn how to do this is just by doing some examples. So let's do a couple of examples. Okay, so sketch the polynomial function. Okay. So let's say we had f of x is equal to 2x plus 3 squared x minus 5. So let's say we have something that looked like that. So let's go using these 3 different steps. So let's start off with the first step, which is basically finding the zeros and the multiplicity. So we're going to start off by setting this guy equal to 0. Okay. The 2 is going to set equal to 0. The x plus 3 is going to be set equal to 0. And the x minus 5 is going to be set equal to 0. Notice that there's nothing here, so that's nothing. Notice that there's a 2 here. Okay, so this is multiplicity 2. Okay, what about this guy? There's a 1 here. This is multiplicity 1. So that means that at this guy, this is going to bounce. Okay, and this is going to cross. Okay, now what is the value that's going to bounce and what is the value that's going to cross? Okay, so now let me solve it. X plus 2 squared is going to be equal, x plus 3 squared is going to be equal to 0. Square root, that's going to go away. So that means that x equals negative 3, this guy is going to bounce. This guy, x minus 5 equals 0, so x equals 5. That means that this guy is going to cross. Okay, so those are the only 2 roots that I have, the only 2 zeros. Okay, all right, so now what would be the next step? So if you look in the next step, I gotta find the end behavior and the number of turns. So number of turns is gonna be n minus 1. So let's look at what the degree is. So here you can see that it's squared. So when I FOIL this guy out, you're gonna have an x squared. And then when I FOIL it with this one, you're gonna have an x cubed. That means that the degree is 3 minus 1, which gives me 2. So that means that the maximum number of turns is gonna be 2. All right, what would be the end behavior? Well, because it's the degree 3, okay, degree is equal to 3, there's no negative on the outside. That means the end behavior is going to look like this, down and up. Okay, so that's kind of what it looks like. All right, so now before we start sketching it, let's go to the third step. Can we find the y-intercept? Remember, y-intercept is x equals to 0. So we're gonna go ahead and put 0. So y is equal to 2 times 0 plus 3 squared. 0 minus 5. 2 times 9 times negative 5. That's gonna give me negative 90. So that means at x equals 0, y is negative 90. All right, so let's plot everything that we have. So let's plot our roots, which is negative 3. So here's negative 3. We have this 5, 1, 2, 3, 4, 5. And then we also have this 0, 90. So 0, negative 90. Down there. Okay, so now let's try to graph it. So we know that it is going to start down here. It's going to go up to negative 3. Now, is it going to cross or bounce? It's going to bounce, so it's going to go back down. So it's going to turn. Okay, so that's my first turn. Okay, and then we know that it's going to cross through the y-intercept at negative 90. And then eventually it's going to have to turn again. Okay, so this is my second turn. That's the last turn that I can do. So I'm going to turn again. And then I'm going to cross at 5, because at 5 we cross. I'm going to cross at 5. Okay, so all we just really need is a general sketch of what exactly this graph looks like. It doesn't have to be perfect, just a general sketch of this. Okay, alrighty. Okay, so let's do a couple more examples. That was part A. Let's do part B. So let's say we wanted to do this problem. Negative x to the 5th power plus 4x cubed. Okay, so let's start off with the first step, which is setting this equal to 0, finding all the zeros, multiplicities. So I'm going to factor this. So I'm going to take out a negative, an x cubed, and I'm going to be left with an x squared minus 4. Okay, that's what I'm left with. Okay, I can even factor this guy here. Negative x cubed, x minus 2, x plus 2. This gives me 0. Okay, so now all of these guys are going to be set equal to 0. Okay, so now let's look at multiplicities. Okay, so notice this guy has a multiplicity of 3. That means it's going to cross. Multiplicity of 1, cross again. Multiplicity of 1, cross again. You can even look here. There's a degree of 1. Okay, so solving this, I divide by a negative. I got x cubed equals 0. Take the cubed root, so x equals 0. So at x equals 0, you're going to cross. I'm going to add the 2 over here. X equals 2. This guy is also going to cross. X equals negative 2 here. This guy also is going to cross. Okay, so all of them crosses. None of them are going to bounce. All right, so then the next step, let's find n behavior and number of turns. Notice that here it's not in factored form, it's already expanded. You can clearly see that the term is degree 5. The number of turns, or the maximum number of turns, is going to be 5 minus 1, which is 4, so it can only turn a maximum of 4 turns. The end behavior, because it's a degree 5, it should go down and up, but notice that it's negative, so it's going to be flipped. So it's going to be up and then down. Okay. So now here we have a 0. 0 right there. Okay. We have a negative 2 right there, and we have a 2 right there. Okay. Now, where is going to be my y-intercept? Okay, well, my y-intercept is going to be when the x is 0. Okay, so you're going to have y is equal to negative 0 to the 5th plus 4, 0 to the cubed, which is 0. So basically, the y-intercept is just going to be the origin. Okay, so 0, 0. So first, it's going to cross through negative 2. Oh, God. I messed it up already. It's going to cross through negative 2 first. Okay. It's going to have to turn to go to 0, and it's going to cross. And then it's going to turn one more time, go to 2, and then continue. Okay. So try your best to draw it. Clearly, I'm not a very good drawer, but that's basically what it's going to look like. Okay, notice that it didn't turn 4 times. This just tells you the maximum number of times that it will turn. This doesn't mean it's going to turn that many times. Okay, so I think the things to really take away from this is that you need to be able to be very good with factoring. Your factoring should be very, very good. Okay, and then because everything else is very, very self-explanatory. So as long as you're really good with the factoring, you should be okay. Just do one more. We won't graph it, but I'll at least try to figure out the multiplicities and the degrees. So let's say you just have this guy. Something that looked like that. So here, first of all, notice that there's no way I'm going to FOIL all this out. Okay, the degree is not 5. Okay, so that's something to kind of know. So let's first start off with the zeros. So let's look at the zeros and the multiplicity. So I'm going to set this equal to 0. Okay, so I'm going to set each of them equal to 0. Okay, so you can see here the multiplicities are very clear. This has a multiplicity of 1, Okay, so this one, multiplicity is 1, so that means it's going to cross. Okay, so at x equals 3, it's going to cross. This guy has a multiplicity of 4, which means it's going to bounce here. So when I solve it, 4th root to the other side is going to do nothing. So x equals -2, this guy is going to bounce. Here, take the 5th root, nothing's going to happen. X equals -3. Because this was an even odd multiplicity, this guy is going to cross. Okay, so this one you didn't need to factor it. Everything was factored already. So the second thing that you want to be able to do is find n behavior. Okay, and number of turns. So what would be the degree in this case? Well, the degree, if you think about it, this is a 1. So I have this is just going to be an x. This is going to be an x to the 4th. This is going to be an x to the 5th. So if you just add up all of these powers, you're going to get a degree of 10. Right? There's no negative on the outside, which means that the n behavior is going to look like this. Okay, just going upward. Okay, so the number of turns will be just 9. You can clearly see that. And I'll leave it as an exercise for you to go ahead and try to graph what this looks like. Okay, it's not that bad. Just the only thing that you have to be very careful with is make sure that this guy is the one that bounces. And also Y-intercept, you want to be able to find it out, which isn't actually that too bad.